Well, here we are. So, my friends, right now in this video, we're going to talk about global partition tables versus the master boot record, or MBR. So, we're going to get started right away. So, this master boot record and GUID partition table, MBR, GPT, these are a couple of different partitioning schemes for hard drives pretty much everywhere, with GPT being the newer standard. So, for each option, the boot structure and the way that data gets handled are unique, right? Speed varies between the two partition options as well. So that makes requirements different. So what are we really talking about? Well, to understand both MBR and GPT, you got to understand what a partition really is. See, partitions are separate sections on a hard drive that the operating system uses to boot and, function, right? So Windows displays them as drives in File Explorer, even though they are on the same hard disk drive, or HDD. So for instance, many laptops have a system partition where everything in the Windows operating system, or OS, goes. Often it's the C drive, plus a hidden recovery partition that can get used to restore the system in case of an accident, or, let's just leave it at that. So another reason to use partitions would be to install multiple operating systems on the same disk. So you could actually have Linux, Windows 10, Windows 7, etc. on different partitions on that same hard drive. So what's MBR then? Glad you asked. MBR manages how partitions are created and organized on that hard disk drive. See, MBR uses BIOS firmware and stores code in the disk's first sector with a logical block address, or LBA, of 1. The data includes information related to how and where Windows resides to manage the boot process and the PC's primary storage and internal random access memory, or RAM, not external memory such as DDR2 and DDR3 memory cards and sticks. So the MBR data stored in LBA1 of the HDD includes the following: Master Partition Table, abbreviated as MPT. This table stores all partition information found on each HDD, including format type, capacity, and some other necessary details. For the OS and the PC to function correctly, they're going to need a record of HDD partitions and sizes, especially in a way to identify the bootable and active partitions. So the MPT provides all that essential information. Master boot code. You'll sometimes see this abbreviated as MBC, M as in mama, BC. So the code here executes the launch of the operating system and manages the configuration for the boot up process to confirm any changes, etc., such as detecting drives and calculating RAM, that's the external RAM, detecting displays, for instance, and some other essential device and configuration information. There's a disk signature as well. Now, every drive needs a unique identifier, which gets created in the form of a signature. This identifier ensures that the correct drive and partition reads and writes data when using several disks, and it ensures proper PC functionality and security protocol for all read-write data transactions. Now, the PC's motherboard, basic input-output system, the BIOS, this is going to look for the device with an MBR. Then it executes the volume boot code from the partition that has it. Then next, the MBR activates the boot sector of the drive to launch the OS. So then, what is a GPT? Well, the GPT stands for GUID Partition Table. And it's just like the MBR, it's going to manage the creation, organization, and partitions on your HDD. GPT uses UEFI firmware, and it also stores disk information, such as partition sizes and other essential data, just like the MBR does in Sector 1. However, GPT uses Sector 2 because Sector 1 is always going to be reserved for MBR and BIOS compatibility. So in GPT technical terms, MBR Sector number 1, LBA1, is LBA0 for GPT, and GPT is Sector 1, which would correspond to LBA1. Yeah. Now, the data is stored in the GPT header. It includes drive information in the form of a GUID partition table. The GUID consists of details on drives, partitions, storage devices, boot information, and other essential data related to the booting and functionality of any particular machine. The GUID partition table stored in LBA1 of the HDD includes all this kind of great information. It's the MBR data, the GPT data, partition entries data, and a secondary, also known as backup, GPT data. So let's put them against each other. What do we get? Well, the main difference between MBR and GPT is MBR has some limitations for modern usage. And I'll tell you, MBR can only handle 4 primary partitions and 2 terabytes of hard disk space. GPT has no partition limit, so you can actually have 10 partitions if you want. However, versions of Windows earlier than 8 can't boot off of GPT drives. So this requirement means that Windows 7's got to use MBR on its primary boot hard drives. Now, another difference is MBR stores all the information in one place, which could get corrupted and fail. So GPT writes information in several drive areas and includes a secondary backup GPT table for recovery if the first one gets corrupted or fails. Now, other than those differences between MBR and GPT, well, GPT can use newer device technologies and is compatible with BIOS MBR functions for backward compatibility of those older non-UEFI devices. And to wrap that all up, boot up is usually a lot faster with GPT and UEFI. So why else would we use a GPT partition scheme? If you get an external HDD or SSD and your PC supports MBR and GPT partitioning, you really ought to format that drive with GPT. So this option lets you take advantage of the faster speeds, unlimited partitions, and significantly larger storage capacities. So then, when would you use MBR? There's a few remaining reasons why you'd want to use MBR. If you deal primarily with drives below 2 terabyte or older versions of Windows, there you go. You might just be better off formatting all of your drives to MBR so that you're not going to risk breaking compatibility with any of your hardware. Now, Windows 7 and onward can use GPT, but unfortunately, compatibility gets based on whether the motherboard and CPU support a UEFI BIOS. Else it's only going to get used on non-boot partitions. You understand that, right? So if you're still running XP, Vista, you certainly don't get involved with GPT at all, okay? That's going to just leave you with the MBR option, which is fine. Keep that in mind. So now that you have wrestled with the difference between MBR and GPT, you're going to be able to correctly choose which partition table scheme is going to work best for your HDD or SSD, your desired number of partitions, as well as the OS that you're working with. Now, while the technical differences can seem overwhelming to understand, perhaps, and apply, just remember, MBR works with drives 2 terabytes or smaller and older OSs, while GPT was designed to support drives greater than 2 terabytes and the newer OSs, as well as a larger number of partitions. All right, so I hope that makes it really clear for you. That's the GPT, the global partition table, and the master boot record, or MBR. Very good. Thanks for hanging in there. But guess what? Yes, we've got more coming up in the next video. See you then.